In the world of acoustic design, there aren't too many things that scare us, but there are some. One of them is echo, especially echo that's reproducing. You hear one, then there's another. Then moments later, there's another. And we're not talking about flutter echoes, little echoes that you can kind of ignore. We're talking about significant echoes, the kind that can take your life. Well, maybe not take your life, but they can certainly mess with your musical performance. Recently, we were presented with the room of 1,000 echoes. Well, not quite. Actually, it was maybe more like a dozen echoes. But what it really was a high school that had a room built that had a serious echo problem. So, given the gravity of the situation, we brought our crack team in, which being another guy, and some test equipment, which consisted of a weird noise and some loudspeakers, as well as some measurement equipment, because we always like to do some statistical things as well as the weird stuff where we make strange noises for no particular reason. And we started making this weird noise in the room, and we could hear it many times. So we started looking into why it was happening. The geometry of this room is relatively benign. If you look at it without paying careful attention, you would think the side walls are just nice and flat. The truth is there are a series of segments. Segments are extremely dangerous. These segments form almost a circle kind of shape, kind of a radius thing. And those are bad. Radius, bad. Keep that in mind in the future. Whenever you're designing a room, radius is bad if the radius is on the inside of the room. So, it is important to look at the geometry as you design a room. Now, this particular one, if you listen to the video that you're about to hear, which is an actual sample of the dreaded 1,000 echoes, could make real havoc with percussion and other sounds, even things that aren't percussion. Just imagine a whole orchestra on stage hearing themselves dozens of times in the audience. Not to mention that every cough in the audience was echoing. All of that was going on. So watch this video, and then we'll talk about the solutions. So now you've heard it, and you know how deadly it is. So what do you do when you're designing a room? You avoid curved surfaces. You also avoid repetitive ceiling panels that are at angles that exacerbate the problem by adding even more reflections into the room. These are things they should teach you in architectural school, but they don't. And you can't blame the architect, because a lot of times school districts will, and this happens to be a high school, but a lot of times school districts will build an auditorium and they don't really say they really want great acoustics. They just want an auditorium. So a lot of times it's the seating plan, the layout of the room, other things take precedence, and then later you find out she got the 1,000 echoes. So in this particular case, they're being caused by most of the side walls up to probably 14 feet off the floor. But there's also some weird stuff going on up at the top caused by the ceiling panels. So the design we're coming up with to solve this problem is a combination of diffusive and absorptive elements that go up quite high on the walls. And the other factor in this room with these ceiling panels that are metal and they ring is we're going to have them damp all of those with fiberglass batting to stop them from ringing, because they sound like an additional noise. When we were in the room testing, it almost sounded like electronic feedback going on in the background from the ceiling panels just resonating. So once this treatment is in, it'll reduce the reverb time of the room, which is always kind of a sad thing to do, but it's the only way to get rid of these echoes other than full-blown diffusion. And diffusion, which we can talk about, is not just some little applique on the walls. Diffusive elements diffuse sound based on their physical depth. So, rule of thumb, 1/7 of a wavelength to diffuse a sound. So if you look at the lowest frequency that's a problem in a particular echo, and you want to diffuse the echo instead of absorb it, you have to look at things that are sometimes 8-9 inches deep. And with ADA rules of what can go on side walls, where people can walk, you can't go more than 4 inches deep. So there's a lot of things you can't do in treating a room like this. But we're using a combination of absorption and diffusion. The absorption will be multiple thicknesses to trim out specific frequencies that are the predominant problems in these echoes. And we're hoping when it's all done, we'll get a room that does not have 1,000 echoes or even 12. We're hoping to get it down to maybe 1, because there's always a return from the back of the room, unless there is no back to the room, in which case you're outdoors, and that's a whole nother set of problems, which comes down to mechanical things like, how do I air condition and heat outdoors? So we really don't want to go that route, because that would be a bigger problem than the echoes themselves.